What's up, guys? It's James Carino here, and welcome back to my channel, Coding with James. If you guys haven't checked out the latest video, I uploaded a video a day ago, pretty much, and it already has 21 views, and I'm grateful for each view, each like, and each subscription on the channel. Thank you for joining my journey in um, coding and just going through leak code interview questions and pretty much, I guess, like in a way, my interview process as well, because you guys are pretty much there viewing me, liking it. So I appreciate that. So check that out, guys. And um, before we get um, before we get to the leak code problem, let's check out make sure you guys check out Genesis Originals. They're an MMA and workout athletic brand. They pretty much have workout clothing for men's and women's. Their latest collection is Conquering the Beasts, and they have a bunch of rash guards, sweat wicking rash guards, um, workout clothing for, yeah, workout shorts for men, women, and hoodies. And I heard that they're going to be releasing in the next couple weeks, so make sure to stay tuned and follow them on Instagram at Genesis Originals. They're also featured on Fox News, NBC News, and the Digital Journal. So this is their Fox News article right here. This is their NBC article, and this is their Digital Journal article. So make sure to check that out. They pretty much have UFC athletes on their roster, and they're Christian family owned company. So okay, so going back, today we're gonna be doing the find peak element, and today I'm gonna be giving you guys two solutions. One solution is a linear solution, so O of n time, and the other one is O of log n time. A peak element is an element that is strictly greater than its neighbors. Given an integer array nums, find a peak element, return its index. So returning the index and not the element. If the array contains multiple peaks, return the index to any of the peaks. Okay, so the first solution is pretty much a linear solution. So we're just gonna go through it one time, and I'm gonna show you guys how I went about it. So I have a variable named peak element. So this is peak element, and I'm gonna set that equal to 0, right? Um, it's an integer, and I'm gonna set that equal to 0. And what I'm gonna do is um, I'm going to iterate through the whole array and pretty much find the highest element, right? I'm going to find the highest element inside this integer array, and I'm going to return that index. So find peak is 0, right? And I'm just going to iterate if the if this is greater, if this, we're going to start at I equals 1 actually, and we're just going to set the um, we're going to set the peak index equal to 0, meaning it's the first element. So we're actually going to start our for loop with this, right? And we're going to compare with pretty much the one before that. So what we're going to be doing is we're going to say, oh, if nums at I is greater than nums at find peak index, or find peak, right? Then find peak is equal to I, right? And then we're just gonna keep going, and now find peak is equal to 1, index, yeah, index 1 pretty much. And we're just gonna keep going. Is this now we're gonna iterate. So I plus plus would lead us to the next one. So now we're gonna say, oh, is nums at I and this index greater than find peak? Is it? If it's not, then we're gonna keep find peak, and we're just gonna keep iterating. And in this iteration, this is actually greater. This index right? The element in this index is actually greater than the element in the index on find peak. So in this case, find peak would be equal to 3, right? Would be equal to index 3. And we're just going to keep iterating. As you see, these are greater, so we're going to end up going through the whole thing, but our find peak would end up being index 5. Find peak would be 5, right? So how do we go about that? I'll just go through the whole code here. So int, we named it find peak, and we set it equal to 0, right? So now we do a for loop for int I equals 1, I less than nums.length I plus plus. So this is the iteration that we said, right? And it's a linear iteration, so O of n. This whole thing is O of n. And we're just going to say, oh, if nums at I is greater than nums at find peak, right, then find peak is equal to I. We're going to set it equal to that index. And then after we go through the whole array, we're going to return peak index, right? So that's pretty much it. We submit that. Oh, find peak, cannot find symbol, find, oh, has to be capitalized. Turn peak, oh, find peak, apologize, oh, find peak. All right, so find peak, we're returning find peak. And yeah, so this is a linear time complexity, O of n, because we're just going through it once, because it's pretty much like the number of elements inside the array, and we're just going to go through it once. So that's pretty much it. Yeah, 100% of Java Online submissions. The runtime is faster than 100% of it. Memory usage 38.7. It's pretty good, right? So that's a pretty good solution, but we can do better because it's asking that we run an algorithm that's O of log n time. And O of log n kind of solution to this is called a binary search. So we're going to do a binary search where we're going to have a left side and a right side to the element, and that's going to give us an optimal solution of O of log n, right? So in a typical binary search, we're pretty much gonna have, let's reset this, that way you guys could see this easier, right? So we're gonna have a left and a right. So in our case, we're gonna set left, right, we're gonna set left equal to 0. So we're gonna start at the first index, and we're gonna set right equal to length minus 1, meaning that's equal to index 6, because 1, 2, 3, 4, 5, 6, 7, and that's pretty much equal to 6, right? So what we're gonna be doing is we're gonna say while the left, right, is less than the right, we're gonna cut it in half, right? So in this case, 1, 2, 3, 4, 5, 6, 7, we're gonna cut it in half. Boom, we're gonna end up with a middle that has 3 in it, right? We're gonna have the middle equal to 3. We're gonna cut it in half, and that's pretty much what we're gonna have. Middle is equal to 3, and we're gonna say if nums at mid, in this case middle, right, is less than nums at middle plus 1. So let's just make this, let's put this here, let's name this middle plus 1. If this is less than this, right? Then we're gonna move this left that we set at the first index, which is 0. We're gonna set left to nums middle plus 1. So we're pretty much checking the right side of the middle now, because this is pretty much finding the peak element, right? So since we cut it in half, boom, we're at 3. That's the middle. And we said that, okay, this is the middle, and we pretty much will check the middle plus 1. And if middle is less than middle plus 1, meaning this is the element in this index is less than the element in this index, we're gonna move the left equal to 4. We're gonna move to that subarray. So left would now equal to index 4, right? And then after that, we're gonna go through it again. So now in this case, we have we pretty much now have, let's take this off. I'm gonna put a line. I'm gonna let's see if I can put a line right. Let's just use this. Trying to grab the arrow. Here. Okay, that's like one of the the reason okay, so what we did was we're working now with the right side of the middle. So this was the initial middle. Now we're working with this. Now the right remained the same, but the left moved. We moved to the higher element. Now we're gonna go through it again, and we're gonna cut it down the middle. In this case, our middle would now be 6. And now we're gonna check, okay, is middle less than the next element, right? Is middle less than the next element? No, it's not. So since it's actually still greater, now we're moving left here, right? So what we did pretty much is we're pretty much like halving and halving the whole subarray. I mean the whole array. So at first it's 1/2 and then 1/4 and so on and so on. So now since this middle, right, and then this is middle plus 1 now in this case, in this second iteration, since this is greater than this, right, since this element middle is greater than this, right is now equal, we're moving, let's actually think about it here. Middle is 6 now, right, and middle plus 1 is 4. And if middle is greater than middle plus 1, we're gonna set right. We're gonna close it down pretty much. That's what we're gonna do. We're gonna say, okay, right is now equal to middle, and right is now index 5, right? And then now is left still less than right? Yes, it is. And we're gonna keep, and in this case we're gonna keep going. Now in this last iteration, right, we're gonna say, okay, or we're gonna have to cut it down the middle again, right? In this case, we're gonna do the calculation to get the middle would be left plus right minus left divided by 2, and the reason being is because we actually don't want overflow, and I'm gonna show that to you later on. So in that case, we're gonna have to do left plus right minus left. So left is 4, 5 minus 4 is 1, right? So 5 divided by 2 is 2. 5 divided by 2 is 2. Remainder 1, right? So in that case, we're gonna do the last comparison, right? And if in this case, this will actually be this is actually going to be the middle now. So left is equal to 4, right? And in that case, middle would be here. Because the whole reason being is 5 divided by 2 is 2. And then, so 5 middle, but doing the calculations, we're gonna end up having 5 minus 4, which is 1, plus 4, which is 5, divided by 2 is 2, right? So middle is 2. And the reason being is because this is the last 3 elements, and we're pretty much going to be setting this to middle, right? And we're setting this to middle plus 1, right? And then now we're actually going to say, okay, is middle less than mid plus 1? Is middle less than middle plus 1? Yes, it is. Now we're going to set left to middle plus 1, as what we did a while ago. I apologize for this arrow. It's, I guess it's yeah, that's gonna be annoying. Okay, so anyway, we're setting left to middle plus 1 in that case, right? Because 5 is less than 6, we're gonna set 4 left equal to 5 now, because it's less than that. So left is now 5 and right is equal to 5. And since our while loop says while left is less than right, in this case now, since we set it equal to middle plus 1, and they're both, left and right is now equal to each other, right? We're going to leave the while loop, right? And we're going to return the left, which is index 5. So that's pretty much it. I apologize for the confusion of what I was saying a while ago, but the reason being is because I want you guys to see how pretty much how the calculation works, how to visualize what's happening in this particular problem, right? So let's actually code what we just said. And right in the beginning, we said that we're going to set the left equal to the first index and the right equal to the last index. So nums.length minus 1. And in our while loop, we actually mentioned that while left is less than right, right? Until it's actually equal to it. Until left is actually equal to right, then we're going to leave the while loop. All right, so now we're going to get the middle. We're going to cut it down the middle, and we're going to say int middle is equal to left plus right minus left divided by 2. And once again, the reason being is if we have a very large array, we do not want to deal with any overflow whatsoever, and doing right minus left will prevent the overflow with Java integers, right? So int middle is equal to left plus right minus left divided by 2. Now we're going to do an if statement here. We're going to do a conditional, and we're going to say if nums at middle, right, is less than nums at middle plus 1, right, we're gonna move the left to middle plus 1, meaning we're gonna now focus on the right side or the right subarray to the middle, right, the right of the middle. That was pretty much us moving from here, moving left from here to here, right? So that's left is equal to middle plus 1, right? Else right is equal to middle. And what we said is if the middle that we had is greater than middle plus 1, then in that case, I didn't get to show you guys, but in the case that Whoa. Okay. So in the case that um let's put left 0, rather than moving left, we're gonna keep left, and we're gonna go from right, and we're gonna cut it this way, right? And we're gonna cut it this way. Right is equal to middle, right? Well, this is the initial middle, so this is middle, right? This was the in the first iteration, we get this middle, and we say, okay, is 3 what did we say? Is if middle is greater than middle plus 1. So this is middle plus 1. And in this case, if this was 2, right? We're gonna cut it in half, and we're gonna set the max or the right to index number 3. And now we're gonna focus on this part. That's pretty much what we said there. And after the whole iteration, when left is equal to right, as I showed you guys, we're gonna return left. So let's see if that works, and hopefully it does. So yes, again, 0 faster than 100% of Java online submissions, 38.8. So it was just 0.1 MB from the initial one that we did, and the runtime is pretty much the same. So that's pretty much the O of log n. The O of log n that they wanted, runtime in this case, linear time and run. So this is a 2 solution video, and I hope you guys enjoyed. I hope you guys were able to visualize what was happening in a binary search in this case. So pretty much, yeah, so that's a binary search. What we did was an iterative binary search for this problem, and we did a linear time O of n solution for this problem. I hope you guys enjoyed this. Make sure to subscribe to the channel, Coding with James. Make sure to like the video once I post this, and definitely check out Genesis Originals. They're a small business, and they're dedicated to pretty much giving like unique designs. They have like unique designs to sportswear and MMA and jiu-jitsu stuff, and they pretty much are they're pretty legit because they're seen on these news channels. So I hope you guys enjoyed. Once again, find peak element interview question by Google and Microsoft as far as I know. So yeah, thank you guys. I appreciate your time, and I appreciate you viewing this, and I hope you guys subscribe and like the video. Keep emailing me, keep programming, and I hope you guys enjoy. Thank you.